Turning a car. It feels like the easiest thing in the world, doesn't it? You turn the wheel, the car goes. Simple. But behind that super simple move, there's like 100 years of engineering, a constant battle between different forces, and some seriously clever geometry. All right, let's get into it and peel back the curtain on the secret science of steering.
You know, it's something you probably never even think about, right? But the answer is this incredible journey. So we're going to follow that signal, that chain of command, from the tips of your fingers all the way down to where the rubber meets the road, to see how your idea of turning becomes actual motion.
Okay, so before we dive into all the gears and the fancy angles, we got to understand what the engineers are even trying to do in the first place. Every single steering system out there, I don't care if it's a beat-up old truck or a brand new EV, it has to nail three fundamental jobs.
First, and this is the obvious one, directional control. The car has to go exactly where you point it, no question. Second, driver feedback. This is so important. The steering wheel needs to talk to you, it needs to tell you what the tires are feeling so you know how much grip you have. And third, low effort. It has to do all that without making you feel like you're wrestling an alligator, especially when you're just trying to squeeze into a parking spot. And these three things, they're always in a delicate dance with each other.
So how do we get from that gentle turn of your hands to the massive force it takes to actually pivot the wheels? Let's get into the hardware. It really all boils down to two main pieces of the puzzle: the steering gear itself and whatever system is providing the power assistance.
So you've got two main contenders here for the steering gear. On one side, you have a rack and pinion. It's super direct, it's really precise, and it gives you awesome feedback from the road. That's why it's in pretty much every modern car you can buy. On the other side, you've got this beast called recirculating ball. It's way tougher, way more robust, and it's built to handle the crazy forces on the front of a big rig. But the trade-off is you lose a lot of that precision and feel. The choice is really all about what the vehicle's job is.
And then you need the muscle, power steering. For decades, hydraulic systems were king. They use a pump that's run by the engine, which makes turning a breeze and gives you this really natural, connected feel to the road. But, and it's a big but, that pump is always running, constantly sucking power from the engine and wasting fuel. So now, electric power steering, or EPS, has totally taken over. It only uses energy when you're actually turning the wheel, which makes it way more efficient. And the huge bonus? It's the technology that makes all those modern driver aids like lane keep assist and automatic parking even possible.
All right, so we've talked about the hardware, the physical parts you can touch, but the real magic, the secret sauce that makes a car feel stable and turn just right, it's not really in the metal, it's in the math. It's this invisible geometric code that's programmed into the car's suspension.
And the first piece of that code is something called caster angle. Okay, just imagine a line that goes right through the pivot points of your front suspension. Caster is just how much that line is tilted backwards or forwards. And pretty much every car you'll ever drive has what's called positive caster, which just means it's tilted back.
So who cares? Why does that little tilt matter? Well, positive caster is the entire reason your steering wheel wants to snap back to the center all by itself after you make a turn. It creates this awesome self-aligning force. The best way to picture it, think about the front wheels on a shopping cart. You push it and they automatically trail behind, right? It's the exact same principle at work, and it's what gives a car that solid, stable feeling when you're cruising down the highway.
But that stability creates a brand new puzzle. Think about it. When you make a really tight turn, say in a parking lot, your inside wheel is tracing a much smaller circle than your outside wheel. If they both turned at the exact same angle, something would have to give, right?
And that something would be your tires. They'd literally be fighting each other, getting dragged sideways and scrubbing across the pavement. It would be terrible for tire wear, and it would make the car's handling feel sloppy and unpredictable. This was a huge problem early car designers absolutely had to figure out.
And the solution they came up with is this beautiful, elegant piece of geometry called Ackermann steering. It's such a simple idea, but it's absolutely brilliant. By just angling the steering arms in a specific way, engineers make it so the inside wheel always turns a little bit sharper than the outside wheel. And what that does is let both tires trace perfect arcs around the same center point. No more scrubbing. Problem solved.
So how does all this hardware and all this geometry actually come together? Well, it's not just about making the car turn functionally. It's about creating a feeling. These principles are what give a car its unique personality, its whole character when you're behind the wheel.
Let's talk about steering ratio. A high ratio, maybe something like 20-to-1, means you have to turn the steering wheel a whole 20 degrees just to make the front wheels turn 1 degree. It feels calm, relaxed, super stable, perfect for a big SUV just eating up miles on the highway. A low ratio, like 10-to-1, is the complete opposite. Tiny little movements of the steering wheel make the car react in a big way. It feels quick, darty, super responsive. Exactly what you want in a sports car.
And finally, what happens when you really push the car to its limits of grip? This is where you run into two famous terms, understeer and oversteer. Understeer is when the front tires lose traction first. The car just kind of plows straight ahead, even though you're turning the wheel. They call it the push. Oversteer is the opposite, and it's a lot more dramatic. That's when the rear tires let go and the back of the car tries to become the front. It starts to spin out.
Now here's the kicker. This is the most important part. Understeer isn't a flaw. It's not a bug. It's a feature, an intentional safety feature. Engineers go out of their way to design the car so that it understeers just a little bit at the limit. But why? Well, think about what a normal person does when they get into trouble in a corner. They panic and they lift off the gas. And that's the exact cure for understeer. It's simply the safest way for a car to fail for the vast majority of drivers.
So, as we start to wrap this up, you can see that engineering the perfect turn is this incredible high-wire balancing act. It's a game of trade-offs between dozens of competing variables. I mean, they have to give you that pinpoint directional control and that crystal clear feedback from the road, but they also have to make it easy to turn. They need that rock-solid highway stability you get from Caster, but they also need that smooth, scrub-free cornering from the Ackerman geometry. And maybe most important of all, they have to make sure that if things do go wrong, the car fails in the safest, most predictable way possible, which means understeer. It's a huge, complex puzzle where every single piece affects all the others. And that kind of leads us to one last big question for the future. For more than 100 years, all of this amazing science has been laser-focused on one thing, connecting the driver to the road. But as we start moving into this world of autonomous cars that steer themselves, you just have to wonder, will this art form, this carefully crafted feeling of control and feedback, will it just disappear? Become a thing of the past? It's something to think about. Thanks for joining me.